All right, guys, so we spent a full week solving word problems using quadratic equations. As I mentioned before, quadratic equations, probably the biggest topic as far as the Regents is concerned, as well as what's going to scaffold for the next couple of years. You're going to be solving quadratics next year. You'll solve them in Algebra 2 Trig, and if you're in, if you go on to take pre-calc and calc, you'll see them there as well, which is why we're spending so much time on them. So today we're going to just prepare to solve them by a method called completing the square, which we have here. So this is not something that is absolutely necessary, okay? So in the sense that, when I was in school, I never learned how to do completing the square. I learned how to factor, and then after that, I went straight to quadratic formula, which we'll do next week. But it's something that shows up on the Regents. It's something that, again, will scaffold into some things you'll see next year in geometry and in Algebra 2 Trig, and it's something that we really should be able to do. And we're going to spend the whole week on it. Normally, I spend 2 to 2.5 days on it, and then I move on to quadratic formula. We're really going to kind of stretch it out because, a lot of these things I think done remotely are a little bit different. So we're going to stretch this out all week. Now, I do want to review again solving a quadratic using 5-step, because some of the word problems that I saw you guys do last week, some of us kind of forgot how to use 5-step in the sense that some of us are still not dividing out the common factor at the end. So just to recap this, and again, then we will kind of shift gears a bit and move on. We multiply, and now we factor. And now we got to bring it back, right? A lot of you guys are putting as your answers here, x equals -12 and x equals 5, which is not going to check, right? We know that if you have a coefficient, if you have a problem that requires 5-step, at least one of our solutions will be fractions. So now we have to replace that coefficient. And we see that only the one on the left has a common factor, which gives me x plus 4 times 3x minus 5. So now we split it up. X plus 4 equals 0. 3x minus 5 equals 0. So the one on the left is the easy one, right? So x is -4. And this is going to be our fractional root, which turns out to be 5/3. So if we wanted to write it as a solution set, we have -4 and positive 5/3. All right, so everything we've done up to this point as far as solving quadratics, we did a couple days of graphing back when I was still with you guys in school, and then a lot of this during using factoring. And now we're going to, like I said, we're just going to prepare to use what's called completing the square. So we're not going to be solving any equations today. We'll spend the entire rest of the week solving them. We're just going to learn kind of the theory behind it, or the approach. So you see that this is not an equation, right? If it was an equation, we'd probably have something like that, equals 0. So it says, what value of c makes this trinomial a perfect square? So a perfect square means that its two factors are the same. So 25 is a perfect square because it has two equal factors. And by the same token, we can say x squared plus 10x plus 25 is a perfect square, because when I factor it, it has the same two factors, right? X plus 5 times x plus 5 will give me x squared plus 10x plus 25. Okay, so now getting back to this one, we want to say, what's going to make this a perfect square? And we're going to say, well, let's think about what it would look like for me to factor this based on what I know. Based on what I know, I've got x times x. And I'm going to say, well, I need to get 6 as my sum. And I want it to be a perfect square, so I need two numbers, the same number, that are going to add up to 6. So I'm going to say, all right, that should work. And then I'm going to say, well, if I multiply x plus 3 times x plus 3, and I do the FOIL, and I combine the like terms, which I'll show you all of it, right? So that's x times x, that's 3x, which gives us the 6x. I end up with this. So that tells me what my answer is. My answer is that c is equal to 9. And we would say, well, how do I check that? The way you would check it is you say, well, let me rewrite this trinomial with x being 9, and let me factor it. And if my two factors, right, are the same, then this is what's called a perfect square. Again, a perfect square is an expression. It doesn't have to be a numerical expression. It's an expression with two equal factors. And our goal eventually is to write it as the square of a binomial, right? X plus 3 times itself can be rewritten as x plus 3 squared. So that's our goal for today. Again, we're not going to solve any equations. Usually I do this lesson and tomorrow's lesson together. I think it's going to really help us to kind of stretch it out a bit. All right, so let's look at this one. We'll do the same thing. All right, I've got x, I've got x. And I know that these two terms are going to be the same. And beyond that, they're the same and they're going to add up to negative 10. So I pretty much know straight out that they have to be negative 5. So if I do FOI, right, the first 3 parts of FOIL, I get x squared, I get negative 5x and negative 5x, which is negative 10x, and I get negative 5 times negative 5, which is 25, which means that c is equal to 25. So I can say, well, let me just really double check this to make sure. If c is equal to 25, then I would expect this expression to have 2 equal factors. And of course it does, right? When I factor this expression, I'm looking for 2 factors of positive 25 that add up to negative 10. And we can tell those factors are negative 5 and negative 5, which means we can rewrite this as x minus 5 squared. Now this part is just a check, right? What we're doing here is we're trying to find out what c is. Now I am going to want you guys to do this check because otherwise you could just put, c is equal to anything. It's easy to just get the answer or get it from someone. But I want to make sure that you guys understand what you're doing. All right, let's take a look at one more, and then let's see if we can come up with some algorithm for this, because it kind of looks like we're playing trial and error here, right? So again, I've got my x, I've got my x, and I know that whatever number is here and here, that those two numbers have to add up to 14, and they have to be the same. All right, so that tells me that they're probably going to have to be positive 7 and positive 7. So now when I check, I get x squared, I get 7x, I get 7x, which is 14x, I get 7 times 7, which is 49. So that tells me c should be 49. And if I want to go to check it, it looks like this. X plus 7, x plus 7. So it's the quantity x plus 7 squared. All right, great. So we've been able to do this. Now, let's see if we can find a faster way, right? Because inevitably I'm doing this, and after we do the first one, the wheels start turning in our brains a little bit, and then we see the second one and we say, I think I know something that's going to work. And then once we see this one, we all know what it is. And what did we do? Well, where did this number come from? Well, it was, right, half of that. And where did this number come from? This number squared. So if I was going back to take a look at something like this with my knowledge that I've got right now, or let's take a look at this one. I would say, well, what's half of negative 10? Well, half of negative 10 is negative 5. What happens when I square negative 5? It gives me 25, and that's how we find c. So for those of you, and I hope it's everyone, that are taking some notes, how to find the value of c, this is it right here. You're going to divide the coefficient of x by 2, and then you're going to square it. So again, going back to this one, 14 is the coefficient of x. Divide that by 2, we get 7, and square it, and we get our 49 right here. So again, this is something that really should be in your notes. Now, this will work if the value of a, right, and by a I mean ax squared plus bx plus c, so a being the coefficient of x squared, is 1. If it's not 1, it's a lot more difficult. And if we were doing it in class, we'd kind of break it down and spend some time on it. It's not something that ever comes up in Algebra 1, though. And it's something that, you'll do in Algebra 2 in a couple years. Not something we have to worry about this year, though we will touch on it a little bit here and there at the end of our lessons. We'll see it again today. So now I'm going to go straight to what I just talked about, right? What's my coefficient of x? It's positive 20. What did I say I'm going to do? Divide it by 2. After I divide it by 2, I'm going to square my results, and I get 100. Right? So we would expect this to be a perfect square if c is equal to 100. And of course, we can check it, and it would look like this. X plus 10, x plus 10, which means it's the quantity x plus 10 squared. Now again, what we're working on today, because tomorrow we're going to actually be solving these things if they were set equal to 0 or some other constant, is finding out what value of c will make this a perfect square. And of course, here the value of c is 100. And we can do the same thing here. This one I'm not even going to check. Take the coefficient of x, divide it by 2. Make sure you put it in parentheses before you square it, and it should be 64. Now, one of the things we're going to notice is C should always be positive, all right? We know that if you square a positive number or a negative number, the result is going to be positive. So if you end up with a value of C that's negative, you're telling me that you didn't really pay attention, you didn't watch the video. All right, and if you wanted to check C minus 8 times C minus 8 will give us x squared, x minus 8 times x minus 8 will give us x squared minus 16x plus 64. All right, so we knew that this was going to happen, right? We're going to, at this point in the lesson, someone's going to raise their hand and be like, well, we've seen all these even numbers, right? These even coefficients of x. What happens if we have an odd number? And I would say, well, that's when we get to solving the equations, you're probably not going to complete the square. All right, so as I said, I never learned this in school. I'll probably say this again throughout the week, meaning it's not something that's necessary, right? I got this far with that being able to complete the square, and I certainly would never complete the square if the coefficient of x was odd. But we'll do it, right? Now that we have our rule. If I didn't have my rule that we came up with a few minutes ago, this is going to be a bit of a problem. So divide 7 by 2, and I get 7 halves, and square it, and I get 49 fourths, which we may be something we don't want to particularly work with, but it's going to work if I check it. Okay, so my answer should be C equals 49 fourths. And if I want to, again, I can check it. What are we going to use? Well, we're going to take the square root of 49 fourths, which is 7 halves. And that will actually work perfectly. If I check this, I get x squared. The outer and the inner parts of FOIL are 7 halves x plus 7 halves x, which is 7x. And 7 halves times 7 halves, the last part of FOIL is 49 fourths. So it will work perfectly. So that rule we came up with doesn't discriminate against odd numbers. If this was different, then we'd have a problem. But we don't care if the coefficient is odd or not. All right, so this is what I was alluding to a little bit earlier, right? Is there a rule we could use? There is. It's pretty complicated, and it's not even worth, honestly, if you had some time and you want to figure it out and you want to message me, we'll talk about it. But for something like this, here's what I'm going to do. How am I going to make C? And again, this is not something we have to worry about so much for Algebra 1, but it's just something we should be able to do. Where am I getting 9x squared from? It's 3x times 3x. So what do I know now? First of all, I know that this is positive. I'm going to say, well, I'm going to have 3x times something, and I'm going to have 3x times that same something. So really, I'm going to have 6x groups of something. So right now, the wheels are turning in my head. I'm going to say, well, if I had 6x groups of 7, that seems like it would give me 42x. And I'm going to say, well, what if I just start it more basic? Well, if I do the FOIL now, I'm going to get 9x squared plus 3x, which is 6x, right? Which is a far cry from 42x. And I'm going to say, well, what if I try 2? And I'm going to say, all right, well, now I get 9x squared. I get 2 times 3x is 6x twice, which is 12x. And I'm going to say, well, let's think about what I did before, right? I'm going to have 3x groups of something. 3x groups of that same something is like 6x groups of that something. So 6x groups of what will give me 42x? 6x groups of 7. So if I check this now, I get 3x times 3x is 9x squared. And then I get 21x in the middle. And I get 21x on the outside, which is 42x. And I get 7 times 7 is 49. Okay, so we can actually do this. Now, if this is not a perfect square, we can't. If it's not a perfect square, like if it was 2x squared, we'd need to divide everything by 2 first and then go back to our original strategy, which is generally going to be very difficult. But if it's a perfect square, this one wasn't particularly difficult. And if I gave you another one, which we'll see in a little bit, I'm sure we'll be able to figure it out. All right, so guys, as I've said before, right, you really do want to be doing this. You want to be pausing the video. You want to be working it out. You want to unpause it and kind of check your work. You don't have to submit it to me if you want to. Some of you guys have submitted it just to see if it was right. And I go over it anyway here. But if you have any questions about it, I'd be very happy to answer them. But again, this would be a good time to pause it. So for the first one, I'm going to do 18 divided by 2 is 9. And 9 squared is 81. So C is 81. For the second one, I get negative 4 divided by 2 is negative 2. And negative 2 squared is 4. So C is 4. For the next one, it's a fraction. So 5 divided by 2 is 5 halves. Squared is 25 fourths. So C is 25 fourths. And the last one I actually have to work with a little bit. So I've got my 2x. I've got my 2x. Right? This is plus, so I've got plus and plus. And I know that whatever I have here and here, I'm going to have 2x groups of that. I'm going to have 2x groups of that, meaning I'm going to have 4x groups of it. So 4x groups of what will give me 28x? Well, to me, that sounds like it should be 7. So if I do 2x plus 7 times itself, I get 4x squared. I get 14x plus 14x is 28x. And finally, I get 7 times 7, which means that c is equal to 49. All right, guys, so as always, any questions, you send me a private message and we'll go over it. But tonight's homework is just about finding c. I want you to show the steps, even if it's just this, which is what it should be. At least then I understand that you know the algorithm and not that you're copying it off someone. So just make sure that you show the steps, and it should take you all of about 5 minutes.